Welcome back, friends. So during the last module we looked at tooth cutting systems that were used for wood. We looked at hand saws, and those hand saws rely on this reciprocating action where typically it's advances and then cuts on the return stroke, or advances and cuts on the return stroke. But the direction of the teeth is most frequently oriented in one direction with what we call reciprocating saws and jigsaws. So let's talk a little bit about some of the things that help us identify which of these tools might be appropriate for what we're trying to do. So I would say that the main distinction that I would make between these two tools is that a sawzall is or reciprocating saw, like this Milwaukee sawzall, is a high quality, heavy duty rated tool that allows us to be able to make a range of both what are called plunge cuts, where we're pushing into a piece of material without an existing opening, for making for making cross cuts in both wood, metal, and in materials that might contain a combination of wood and metal. And where we see that combination of wood and metal, and where we see this tool really excelling, is in demolition work, where contractors are using saws like this to cut openings into walls and to cut through structural elements like 2x4s or 2x6s that might have nails in them. So it is really, more than anything else, it's used as a demolition tool within the trades. But in studio practice, we can find it to be an extremely effective and useful tool because of its heavy duty capacity and because the wide range of blades that can be purchased to work with reciprocating saws like this sawzall. We're able to cut through tubular material that's made out of metal or PVC. We can cut through wood products, and we can rely on that tool to be able to do it with what we call a long stroke, and that's this reciprocating action of this allows us to be able to benefit from using a longer length of teeth along a blade's edge. So we can get through thicker cross sections, we can do it with a lot of power, and this particular model has a variable speed or stroke trigger that allows us to work at lower speeds for cutting through materials like metal, and higher speeds for fast cutting with coarse blades going through wood. Let's just take a quick look at some of the blades that are available. The one thing I can tell you about blades for any cutting tool, whether it be a scroll saw or a jigsaw, is that that's the one place where you don't want to go cheap. You want to buy a high quality blade that's designed for the material that you're working with, that's made by a top-notch or reputable manufacturer that doesn't necessarily make things for hobbyists or home crafters, but that makes these blades for commercial applications. And because it's cheap blades are going to perform poorly, and they're not going to last very long, and you're going to end up wasting your time, spending more time changing blades than actually cutting through material. So here you can see this is like what they call a handy pack that comes with a collection of different types of blades. So again, remember, we're looking at the teeth per inch and the set of the teeth, all determine what materials are well suited for. So here you can see this is a 6-inch 14 TPI bimetal blade, and it's alloyed with cobalt, so that we talked a little bit before about carbon steel for wood, high-speed steel for metal, bimetal blades, which have hardened teeth and a flexible back, which is what you really want when you're doing demo work or going through hard materials. That cobalt alloy gives it a resistance to wear that really prolongs the life of the blade and allows it to cut through hard materials. So then you see here we have a short and stubby, which means we're going to have a shorter stroke, but it's an 18 TPI, right? So there's the more teeth, thinner cross section, less teeth, thicker cross section. Then here we have a 6-inch. That's the same as that heavy duty 1/8 inch and above thickness. Another 6x14, and here we have what they're called a general rough in for nail embedded woods. So this is a 6 TPI bimetal blade, and again remember the distance from the top of the blade to the bottom of the blade determines both how tight a radius it can turn, but also how small a space it can fit into and how rigid it stays. So I would expect that a blade like this that has parallel sides and a mitered edge will hold a line truer than something that has a notch like this, because that thinner edge has more of a tendency to flex. And on the back of that package you can see there's a little chart and it shows you what materials that's appropriate for. So I like Morse, I like Lenox. I mean, Milwaukee typically makes pretty good quality blades, so I like them okay for these blades. But know also that there are also specialty blades that you can get, like this silicon carbide covered blade, where it's actually an abrasive grit that's bonded to the surface of that blade for cutting through things like ceramic, glass, tile, and some stones that are softer stones like limestone. There are also handy holders like this that you can hand hold those reciprocating saw blades, and this can also be positioned in a number of different angles. In addition to holding on the blade, it could be positioned in a number of different angles to allow you to get in, reach into a spot where you might not necessarily have been able to get in and reach in with a tool like this. So that's our Sawzall, and we'll do some demo cuts with that in just a second, and we'll show how to install blades. Over here we have a jigsaw. This is a Bosch jigsaw. This is one of the first tools that I bought for my own studio practice when I got out of grad school, because it has such a wide range of applications. It's not necessarily a tool that I would choose for a super straight cut, but one can make good straight cuts in a range of materials if you have the proper blade. And again, it's about the frequency of the occurrence of teeth. For ripping with the fibers of wood, we want a coarse blade to strip out those fibers. For cross-cutting, we want a finer blade. There are also what are called progressive blades that are a combination of different size teeth on that blade. And then we have specialty blades for plastics and fiberglass and different types of metal. And again, different alloys of different blades for different applications. We also have some really some blades that people always seem surprised when I point these out to them, like they've never seen this before, but I came across these knife edge blades here, this wavy set knife edge blade and the straight knife edge blade. And these blades are amazing in foam with some medium density rubbers. They also do an excellent job cutting through leather, and they also work to cut through microcrystalline wax. So, a lot of usefulness in this one tool. They also make, much like the bonded blade that we saw here, they make blades that are, again, come with a coating of carbide grit bonded to the surface, or diamond bonded to the surface, that, again, to allow us to go through things like glass and ceramic and almost all the cutting procedures that we're going to do with harder materials are going to be lubrication. The only dry cutting we're going to do is going to be plastics and wood. So let's go into detail about how to inspect our tool in advance of using it, and how to make sure that if we're needing an extension cord, that we have the right cord for the job, and some of the different functions of these tools. Knowing what a tool is capable of is an important part of understanding its potential and what it can be productively used for. But anytime we're working with tools of any kind, we need to talk about personal injury protection. And anytime we're working with tools, we need to at minimum have proper eye protection on, which is eye protection that is appropriate for the job that we're doing. So safety glasses might be an appropriate choice if they fit you properly, but eye protection should be scaled to the job that you're doing. So if I'm doing something like working on something that's over my head and material is raining down on me, I might choose to use goggles instead of using safety glasses, or using a face shield in addition to safety glasses or goggles to increase or reduce the risk of getting any debris in my eye. Because I can tell you this from my own experience, that eye injuries are naggingly painful, take a really long time to heal, and they're going to sideline you from whatever work it was that you were doing. So eye protection is paramount. We also have to make sure that we're always using proper hearing protection. My preferred choice is sound dampening headphones that are rated for the amount of noise, or the decibel level of noise that's produced by that particular tool. And again, this is based on what it is that we're doing. If I'm cutting through a piece of wood, there's a lot less noise than if I'm cutting through a piece of sheet metal or a piece of thin-walled tubular material that makes a hell of a racket. We also want to make sure that we're using proper respiratory protection, and again, that needs to be scaled to whatever the job is. If I'm cutting through materials that are generating fine powders or dust that I know present a respiratory risk, that I'm going to use a level of respiratory protection that is appropriate for what I'm doing. Everybody's been hearing all about N95s, and that's sort of our standard for what we use in most studio practices, because it has the capacity to eliminate 95% of small particulate. But again, it has limitations in terms of what it can protect us against. We also want to make sure that we're always keeping our hands a safe distance away from anything that can cut, crush, or bite. Our rule of thumb is you extend your pinky and your thumb out, and that represents the safe distance you want to maintain from anything that's hot or sharp that could cut, crush, or injure you in any way. It's also important before we get started working that we make sure that we do an inspection of the tool so that we know it's in good working order in advance of working. And when it comes to working with tools that are using electricity, that means that we're going to carefully inspect the cord to make sure that there's no obvious damage to the cord, that both prongs of the plug are secure and intact, and that, of course, when we're working with electricity, we're never going to work with anytime there is standing water that would put us at risk of getting potentially electrocuted. We're also going to make sure that we're often going to need to use an extension cord to give us a longer reach, and it's very important that you understand that that extension cord is has the potential to restrict the flow of energy if that extension cord is a smaller diameter than the cord on the tool itself. So this cord, which is a 18 gauge 2-wire, should never be plugged into something like a household extension cord that's made out of lighter gauge wire. Because if it's trying to pull current through a thinner wire, it's going to cause that motor to overheat, which will cause that motor to, premature wear to that motor. And possibly, if you run for extended periods with a cord that's too small or too long, because the longer the cord is, the more resistance it has to get that energy to the tool where it needs to be, then that could also be a factor that we need to consider. So we have what's called a D handle, a trigger that's a variable speed or stroke trigger. We have the foot of the tool, which tilts to accommodate different types of cuts, but should always be in contact with the material that you're cutting through. We have a chuck, which is secured with an Allen key, which is held on the end of the cord, and it is imperative that you make sure that you always have your tool disconnected from its power source anytime you're swapping out blades. So that's why typically these keys that are used for opening and closing these are connected to the end of a plug like this, so that it reminds you to unplug that in advance, right? So we take our Allen key, we go in, and I'll often just pull this off the cord because it's easier to maneuver. So left is loose to unlock. There's a pinhole position that inside of that jaw that the blade will seat onto or hang up onto or catch in place on that little stud that corresponds to the opening. And then we go ahead and take our Allen wrench and turn that in until it clamps securely. Right is tight. I'm just going to hand tighten that and then double check to make sure that that blade is secure in place. I'm going to go ahead and now plug into my power source. And when I'm working on job sites, I really like extension cords like this that allow me to be able to lock and unlock the head of that so that it doesn't pull out when I'm working on a job site or going up a ladder or pulling that cord across the studio. So my power source is now connected, and this is a two-hand operation. My primary hand is holding the D handle, which has my trigger, and my alternate hand is holding the body of the saw at a safe distance away from that cutting surface. So if I pull the trigger a little, I get a little bit of movement. And if I pull that trigger more, then it increases the speed or the frequency of that stroke. Lower speeds for cutting through metallic materials, and higher speeds are used for cutting through wood. Let's go ahead and move over to our materials and do a couple of demonstration cuts. Okay, I've got my material secured in place, and I'm going to firmly grip my tool, come to rest the foot on my material with the blade elevated above the surface of my material. I want to wait till that tool comes up to full speed before I engage that material. Here we go. Before I complete that cut, I'm going to do a quick double check and make sure that there's nothing in the path of that material, so that when I exit the bottom of that material, I'm slowing my rate of feed so I don't suddenly lunge forward. My body's clear. I have a wide stance, so I'm stable. Here we go. Allow it to come to a full stop before you withdraw the tool. So you can see it's cutting on the back stroke because the teeth are facing backwards. So any tear out I'm get is going to be on the side that the blade exits. I can also do a plunge cut into a piece of material by bringing the foot to rest on my material, starting slowly. And again, coming to a complete stop before I withdraw that blade.